We know that 1 is not equal to 0.9. They just differ by 0.1. 1 is also not equal to 0.99. And 1 is also not equal to 0.999. What about 1 being equal to 0.999 and so on? The answer is yes. An obvious question is, can we prove that 1 is equal to 0.999? An obvious answer is yes, we can prove, and we will prove it. Let us prove that 1 is equal to 0.999 and so on. Let us try to divide 1 by 9. Of course we cannot, so we use the decimal. And after decimal we can put as many number of 0 as we like. Now 9 times 1 is 9 and we subtract to get the remainder 1. Again 9 times 1 is 9 and we subtract and get the remainder 1. We can continue this process to obtain 1 by 9 equal to 0.111 and so on. However, we want to show 1 is equal to 0.999. So what we do is we multiply both sides by 9. We multiply left hand side by 9 and also the right hand side. 9 we can cancel it out and we obtain 1 equal to 0.999 and so on. However, you may not be convinced with this. We got another proof. Let us assume that we do not know how much this number 0.999 and so on is equal to, and let us call this number be equal to x. We multiply both sides by 10. We multiply left hand side by 10 and also the right hand side to obtain 10 number of x equal to, you see that 0.9 if I multiply by 10 we get 9. 0.99 if I multiply by 10 I get 9.9. 0.999 if I multiply by 10 I get 9.99, and if I continue this one we get 9.999 and so on. Okay, we got 10x equal to 9.999 and so on. However, we know that x is equal to 0.999 and so on. Let us subtract. When we subtract one number of x from 10 number of x, we will be left out with 9 number of x. When we subtract 0.9 from 0.9, we'll get 0. When we subtract 0.09 from 0.09, again we'll get 0. So it turns out that 9x is exactly equal to 9. Well, can we solve this equation? Of course, yes. We can cancel 9 out and say that x equal to 1. So the unknown number x, that is equal to 0.999 and so on, turns out to be exactly equal to 1. Is there another proof? The answer is yes. Let us write 0.999 and so on as a sum of 0.9 and 0.09 and 0.009 and so on. Observe that this is a geometric series. With the first term a equal to 0.9 and the common ratio r equal to 0.1. Now a geometric series converges, or the sum of a geometric series is known if common ratio is greater than 0 and less than 1, or if it is negative, the common ratio lie between -1 and 1. In this case, common ratio is less than 1, so the geometric series converges. And the sum is given by sum equal to a by 1 minus r. In this case, a equal to 0.9, common ratio is 0.1, 1 we copy as it is. Okay, we see that 1 minus 0.1 is 0.9, 1 minus 0.1 is 0.9, and we got 0.9 on the numerator. Again, we can cancel 0.9 and 0.9 out, and we will be left out with sum. So the sum of the series is exactly equal to 1, or 0.999 and so on is exactly equal to 1.